Today, there's a few things that I wanted to kind of talk to you about that I thought needed a little bit more clarification than you could get from just reading the notes. The solubility curve is something that I don't think you've ever been introduced to before. And graphs are so important because of the ACT that I really wanted to spend a little bit of time on this, explaining it to you. So if you look at the x-axis, you have temperature in degrees Celsius. And then on the y-axis, you've got solubility, and it's grams per 100 grams of water. So it's basically how much will dissolve, how many grams of solute, so that is the solid, will dissolve in 100 grams of water, which is the solvent. And you're also going to have practice determining the solute and the solvent today, and I'll talk about that here in just a second. But let's just look at the different compounds that we have. So the green line is NaCl, sodium chloride. Notice that the solubility does not change as you increase the temperature. It pretty much stays the same. Now it might, I guess it is increasing just a little bit. But basically, if you just look at this, you can put about, what we say, maybe that is 35 grams of salt in 100 grams of water, pretty much at any temperature. It does increase just a little bit, but it doesn't increase a whole lot. Okay, so if we look at this yellow line, which is potassium nitrate, notice that it increases a lot as you increase the temperature. So notice, let's just say how much KNO3 would dissolve at 40 degrees Celsius. So if you look here, you've got 40 here, and you see where the yellow line is, and it would be that there are 80 grams of KNO3 would dissolve at 40 degrees. So here is 40, and then you're going to see where it crosses the line, and it crosses right there. So then you look and you see that it is at about 80. Now you don't have to be unbelievably exact with this kind of stuff, but you get the idea of what we are looking at. So I will go over that. I will show you the worksheet here in just a second, but I wanted you to look at this. So this is very kind of important that you can look at these different things and analyze what's going on. So let's say that I needed to dissolve 50 grams of this potassium bromide. What temperature would I need to get it up to? Well, this is 40, this is 60. So you don't have to get it up to that high of a temperature. So to dissolve 50 grams of it, 50 is about right here. So really at 0 degrees Celsius, 50 grams would dissolve because it is below this. If we wanted to kind of go up and say, what about 75 grams, then you would see that you're going to have to kind of go over, and you'd be like, all right, I got to get it up to 50 degrees Celsius before I can dissolve 75 grams. So those are just some things that you can look at with the solubility curve. All right, now how dissolving works. We haven't really talked about water being polar, but it just means that it has a little bit of a charge to it. And that's what makes it able to dissolve things really, really well, especially ionic compounds. So if we think about a salt molecule, you've got on the salt molecule, you've got a lot of negatives and positives. And so what happens with this is it is attracted, so the negative end is going to be attracted to the positive end of water, and that is going to separate it out. And that is why ionic compounds dissolve in water so good, is because the positives and the negatives attract one another. Remember that opposites attract, so they're going to attract one another. And that is just, we call that dissociation. So that is just the process in which ionic compounds separate into ions, usually in a reversible manner, which just means that if you evaporated off all the water, it would go back into that solid form. And if you notice with these notes, you only had to write down the highlighted portions of those notes. You did not have to write down everything. But at this point that you're watching this, you should have already done the notes. But let's look at your two assignments for today so I can go over that for you. So the solubility curve practice, that is what we just kind of went over. And you need to kind of look at the graph is pretty much the same. Now it's not color-coded, but you've got different types of lines here. And you've got substance A, which is the solid line. Substance B is the dotted line, and substance C is the dashed line. So there's going to be different questions that are asked about this. So the first one says, what substance is most soluble at 0 degrees? What substance is most soluble at 100 degrees? Well, you're just going to look. Notice, just look that substance C, which is the dashed line, you can dissolve almost 50 grams of substance C at 0 degrees Celsius. So the answer for the first part of 1 is going to be substance C. Okay? Now, what substance is the most soluble at 100 degrees Celsius? You're going to look, and that's going to be the solid line. Here's 100 degrees. The solid line is substance A. So I gave you the answer to number 1. Let's go ahead and look at number 2. So how many grams of substance B will dissolve in 100 grams of water at 60 degrees Celsius? So basically the 100 grams of water is covered over here. You're really not worried about that. You're really just worried about this 60 degrees Celsius. So if we look right here, we've got 60 degrees Celsius, and we're looking for substance B, which is the dotted line. So I'm gonna draw this up. I'm gonna go 60 all the way up to where the dotted line is. Oh, that's pretty cool. Did you see how it magnified that for me now? It's not gonna do that again. That was a cool function I didn't know that it would do. So then you just have to kind of look over, and you can see that it's a little bit above 50. You might want to say 51. So the first one is 51 grams. Okay? And then it says how many would dissolve in 400 grams of water at the same temperature. Now, this question is, you just have to do a little bit of math. It's super easy. If we're at the same temperature, if we have 400 grams of water, all you've got to do is multiply 51 times 4. Okay? So if we did that, 51 times 4, let me get out my calculator real quick. So 51 times 4 is going to be 204 grams. So super easy. You might have to do a little bit of that as you're going through, but just answer every question. You might not get every single one of these correct, but try. Make a logical attempt to answer all these questions. This is really, really good practice for the ACT. All right, let's look at one other example. Now, this solute solvent practice is very, very easy. So the solute is what is being dissolved, and the solvent is what is doing the dissolving. I'm going to keep the fruit juice one. You guys should know that one. That one's very easy. Let's just look at maybe this one about air. That might be a little bit more confusing. So we don't normally think about gas and gas, okay? But it can happen. So the solvent is basically the air. And then what is being dissolved in that is going to be, I'm just going to use the symbols, nitrogen, argon, and oxygen. You don't have to use the symbols for that, but that was just a little bit easy. That one is a little bit confusing for you, I believe. But I think all the others should be pretty easy. Okay, I have not done this cup magic for you, so I might need to do this one with you. acetone will dissolve styrofoam cups. I don't have any acetone. I have not done this demo for you. But on this one, the solvent is going to be the acetone. And acetone is used as a solvent. Girls, acetone is what takes off your fingernail polish. So it is dissolving the fingernail polish. So the fingernail polish would be the solute, what is being dissolved. In this, the peanuts, the styrofoam peanuts, are the solute, and the solvent is acetone. Acetone is a very good organic solvent. So again, I think you can do the others. I think that is the main thing that you guys needed help with. And I guess I forgot to kind of tell you guys, I am not sick, but I have been exposed to someone with COVID, so I'm going to be at home. I'm going to try to do some live Google Meets when I get a little bit more used to you guys. I'm not used to you guys being at school and me being home. So we might do some Google Meets. I am at home. If you have any questions about this, you can email me, and we can do a Google Meet today if you need to. But just let me know. Email me, because say I am working from home. I am not sick, so I will be able to answer any of your questions. I will be at my desk here at home working while you guys are in class working. So let me know if you need anything, and I will see you in a couple weeks. All right, see you.